Hi guys, today we're going to be working on the examples from 2.2, which is algebraic skills from your Year 11 Jack Plus textbook. So this is a precursor to the quadratics work, and quadratics is quite a big part of Year 11 methods. We just want to go over some of the skills we need before we get started on the actual quadratic chapter. So look, the first one here does look a little bit tricky, and I can see I've got an x in everything, so look, I'm going to take that out first, and I'm going to have 2x squared plus 5xy minus 12y squared. So that's just taking an x out, and now I have a quadratic trinomial, and a lot of people would leave it like this because they would not realize that you can actually cross multiply what's in the brackets here. So I always use cross multiplication when I have quadratic trinomial, whether it's monic or non-monic. So that's, if you have another method, that's fine. But I think this method is the best because I think you can really see how the numbers work and how the factorization works. So 2x times x is 2x squared. And then for negative 12y, I'm going to say, well, 3y times 4y is 12y, but I need a negative, so let's make that negative. Let's see if that works. So now I do the cross multiplication. So let's go this one first. Negative 3y times x is negative 3xy. And then I'm going to 2x times 4y is positive 8xy. So negative 3xy plus 8xy equals positive 5xy. And the goal of this cross factorization is that we get the middle term. And we have. So this is correct. And it means that within our brackets, we can factorize to this. So don't forget the x out the front. People will forget that and lose a mark. And we're left with 2x minus 3y and x plus 4y. So that would be our fully factorized form. Again, I will make note that being able to do your cross multiplication in order to get your two sets of brackets is a really important skill, and we're going to use that heaps. So if you're not quite sure of that, it might be good to look back over some Year 9 or 10 examples and do some of those. Let's move to the second one, and this one's a little harder. It's got 4 terms, so we'll be using some sort of grouping. And when we group, we can either group 2 plus 2 or 3 plus 1. And I feel like it's going to be a 3 plus 1 example. Let's have a look. I'm going to subtract this part. So x squared minus 10x plus 25. And notice how I've taken the negative out. So that means that all of these, or both of these, I should say, change the sign. So this here, you might already notice that this is a squared minus 2ab plus b squared. Oops. And that would factorize to a minus b squared. But even if you didn't, you could use cross factorization. X times x is x squared, and neg 5 times neg 5 is 25. So x times negative 5, negative 5x, x times negative 5, negative 5x, negative 5x minus 5x is negative 10x. So that gives us the middle term, and it means that in our brackets we've got x minus 5, which of course is x minus 5 squared. So let's put that 4y squared back on. So we're doing pretty well. We have factorized, quite a big part of it. This is a rule you want to know. So this comes up all the time. This is from Year 9, and you definitely would have covered it in Year 10 as well. Now, though, I can go a little further with this, and I can see I've got 2 terms and a negative in between. So we have an identity that looks like that, and that's a squared minus b squared. Difference of perfect squares, a minus b, a plus b. So, well, in this case, a squared is 4y squared, and b squared is x minus 5 squared. So that means b is x minus 5, and a is 2y. So be careful on the a, because people are going to say a is 4y, and of course that's not the case. You need to square root all of it, not just the y squared. So let's put that together. So we've got a minus b, a plus b. Let's do the a minus b. A is 2y minus b is x minus 5, and I've got to subtract all of that. So notice I'm subtracting that whole thing. I put brackets there. And then I've got a plus b. So a plus x minus 5. And you don't really need the brackets for that one because it's an addition, so it's not going to alter the sign of the negative 5. But look, for the sake of completeness, I'm going to put it there as well. That becomes 2y minus x plus 5, negative x, negative 5, which is positive 5. And of course, the next one, 2y plus x minus 5. So, have I left anything off the side? No, I have not. So that will be our final answer. So that one was quite a good one because it covered 2 factorization of quadratic rules. It's got a squared minus b squared there, and it's got the a squared minus 2ab plus b squared. The other rule, which we didn't see here, was a squared plus 2ab plus b squared, and of course that's a plus b squared. So that one we didn't use, but just for the sake of, noting, it is also a rule we want to know. Let's move on to the third one. Now, in the book, I believe they tell you to use a substitution, but I rubbed that part out, or I omitted that part because I would expect that you would be able to see that you would use a substitution here. So I'll show you what I mean. I'm going to say let z equal x plus 1. Now, I think Jack Plus uses p or a or b or something, but I always use z as my pronumeral of choice, and it really doesn't matter which one. Don't use x, obviously, because we already got an x, so, plenty of letters to choose from. So that means 7z squared minus 8z plus 1. So you see I've put a z in the place of x plus 1. So I've just gotten rid of the x plus 1s and changed them into z. So let's now cross-factorize. Cross-factorization coming up again, I think for the third time just in these examples. 1 times 1 is 1, but because I got a negative in the middle, no doubt they will be negative. So 7z times negative 1 is negative 7z. Z times negative 1, negative z. Negative 7z minus z, or minus 1z if you like, is negative 8z. And indeed that is what we want. It's the middle term. Again, notice how showing the cross-factorization is really good because it's difficult to make a mistake. You really would be hard-pressed to make a mistake because you actually check that it works here. So I really recommend this method. So in our brackets we have 7z minus 1 and z minus 1. And look, a lot of people will leave it at that, and you would get some marks. You've done quite a lot of work there, so that'd be like 1 out of 2 marks if there's a 2-mark question. But of course, z has nothing to do with it. What we actually are looking for is x. We're not solving. It does not have an equal sign, so we cannot solve. But we are factorizing in terms of x, not in terms of z. So I'm just going to substitute that back in. So z is x plus 1. Remember how we said that in the beginning, let z equal x plus 1. And you want to say that if you're substituting z or a or b or whatever, you want to make note that that's why you're doing it, or that's what you've done. That's important. So I'm subbing back in the x plus 1 and x plus 1 minus 1. These brackets here are absolutely important because otherwise you'll forget that you need to times the 1 by 7. In the second bit, well, it's not as important, but still I think for the sake of completeness you should put it in. So we get 7x plus 7 minus 1 and x plus 1 minus 1. And that leaves us with our final answer of 7x plus 6. And x plus 1 minus 1 is just x. And actually that x we won't leave in the brackets there. I'm just going to put it in the front. So I'll pop it here, delete it from there. This would be our nicest form of the answer, not to leave the x at the end. So this is our final answer here. So as you can see in those first 3 examples, really important that you know how to use cross-factorization, so of quadratic trinomials. And again, if you're not quite sure of that, you should look at some year 9 or 10 examples of monic and non-monic factorizations for trinomials. Let's move on to the factorization of the cubic expressions here, and we have a negative one and a positive one. Now, these rules are by far not as important as the squares, so perfect squares and the a squared, a minus b, a plus b rules, but still good to know them. So let's have a look at x cubed minus 27. And I can see that that looks like this. So I can say that looks like a cubed minus b cubed, and that will factorise to a minus b, a squared plus ab plus b squared. And I like to remember it that if it's got a negative in it, then you put the negative first. If it's got a positive in it, the positive goes first. So we're dealing with the negative though, so I'll keep to that. So let's identify a and b. A is x and b is 3, because 3 times 3 times 3 is 27. So the cubed root of 27 is 3. So let's now pop them in. So a minus b, and then a squared plus ab, so 3x plus b squared is 9. So that's that. That's all we can do there. We will just leave it like that. So that is our answer. That's just a matter of using the rule really, and I guess remembering the rule for when it comes up. Let's go to the second one, which again is not really that bad. So this time, I'll just maybe scroll over this way. So we've got 2x cubed, I think it was plus 16, yes. Now you can't see the rules anymore, but I'll write it out. So in this case, what I'm going to do, I'm going to remove the 2. So there's something in front of the x cubed, and if I cube root that, well then the cubed root of 2 is not nice. We don't really want to work with that. So I'm going to say, well, that equals 2x cubed plus 8. And you see that is nice because the cubed root of 8 is 2, and the cubed root of x cubed is, well, x, so that they're nice to use. So this rule is going to be a 2a cubed plus b cubed. And our rule for that is going to be a plus b, so the plus comes first. It's a plus in here, and then a plus is going to come first in there, and then in the next bracket is going to be a squared minus ab plus b squared. So it's a little weird because it's got a minus in it, so people kind of forget that. But I think if you can remember that the pluses, if it's plus, the plus comes first. If it's minus, the minus comes first. That's quite handy. So let's see, a equals x and b equals 2. So a is the cubed root of x cubed, so it's x, and let's use a different colour perhaps. And 8, the cubed root of 8 is 2. So 8 is b cubed and 2 is just b on its own. So let's sub it in to make the rule. Don't forget the 2 out the front. X plus 2, so a plus b, and a squared, so x squared, minus ab, so minus 2x, plus b squared is 4. So let's now just get rid of those big brackets. Oops, not squared at all, plus 2, and x squared minus 2x plus 4. And that would be our final answer. So those cubes, we want to remember how to factorise. All right, moving forward, I think there's 2 more, maybe 3 more. 3 more. Okay, so this one is going to be, we have to simplify. So at the moment you can't do anything. What you definitely can't do is cross out x's like this. That's definitely wrong. So you need to be able to factorise, then cancel. So I can see in the top, so I'm going to write this is 1 and this is 2. So number 1, x squared minus 2x. I can take out an x, and I'm left with x open brackets x minus 2. And then for the second bit, well, this looks like, well, this not looks like, it is a quadratic trinomial. So I can say x times x is x squared, and then 6, well, let's say, how about 3 times 2 is 6, and because I've got a negative in here, it's going to mean I need negatives. Negative 3 times negative 2 is positive 6. Let's cross factorise it. So x times negative 2 is negative 2x, x times negative 3 is negative 3x, and that equals negative 5x, and indeed that is the middle term. So that means we have worked out what is in our brackets. So for our bottom bit, we've got x minus 3, x minus 2. So let's put it together. So in the top is 1, which is x minus 2. And in the bottom, we've found x minus 3, x minus 2. And now we can simplify it, cancel down. So step 1, if I had to write the steps here, would be factorize everything. So I've factorized everything. Let's see what we can cancel, that and that. So our final answer will be x over x minus 3. And we cannot simplify that anymore. Some people, I already know, are going to cross out these, and that's completely wrong. You can't do that. You can only cross it out in everything. So if this was a 3x here, sure, you could cross out all 3 of the x's, but it's not. So you are not able to do that. You need to just leave that as it is. So moving on. This is a division of fractions. So step 1, keep, change, flip. And there's a great video about keep, change, flip. I can send that to you as well, if you so wish. So we've got x to the 4 minus 1 over x minus 3 times. So keep the first one the same, change the division to a multiplication, and flip the last one. Okay, step 1. Step 2, factorize everything. And again, I'm going to label them. So you know what, I might make it look nice. So make that yellow, that green, that blue, and how about pink? So that pink. So we're going to factorize each of those parts. So I'll start with the yellow one, and that is x to the 4 minus 1. Now let's have a look. This is a squared minus b squared as well. So a squared is x to the 4. b squared equals 1. So if a squared is x to the 4, a by itself, the square root, is going to be a squared. And, well, b is just going to equal 1 because the square root of 1 is still 1. So now we can say that we've got, well, x, whoops, that should be x, shouldn't it? So we've got x squared minus 1 and x squared plus 1. So we can factorize this more, but I'll leave it for the minute because we may not need to. We might find we can actually just cross that out as it is. So this, just to be clear, it's a squared minus b squared, which is a minus b, a plus b. So this is difference of perfect squares. Again, in a year 9 thing, but also covered quite extensively in year 10 quadratics. So that one you need to know. Let's go for our green. Note the green is just as it is, so we actually don't need to do anything with the green. I'm just going to write x minus 3 as it is, because we've considered it, although we cannot factorize it. The same with the blue bit. We can't factorize that. We can just leave it as it is, 1 plus x squared. And, well, actually, we can't factorize the pink one either, so I'm actually a bit disappointed with this one. There's only one real factorization that we need to do. So, look, in any case, let's write it. Let's write all of these in their spots and see what we can cancel down and if we need to do any more. So this x to the 4 minus 1, that's that yellow bit. So I can put that in as x squared minus 1, x squared plus 1 over x minus 3, we can't do anything, times, remember we keep, change, flip, 3 minus x, couldn't do anything with that, and 1 plus x squared. So there's one thing you can probably see straight away that's easy to cancel. X squared plus 1 is the same as 1 plus x squared. So that's fine. I think everyone would cancel that pretty well. These two look similar, but they're not the same at this point. So what I'm going to do, I'm going to see if I can sort of change them so they are the same. So 3 minus x, let's take out a negative there. So take out the -1, and I'm left with -3 plus x, and that is -1 times x minus 3. So yes, I can. I'm going to write that there as negative, and I'm going to leave it as a 1. You don't need to write the 1 there, but you'll see why in a minute I've done that. And then, well, if I've got that, it means that these two can cancel out. So now I'm left with a -1 up here. There's a 1 in the denominator there. I don't really need it, it's just over 1. And x squared minus 1 there. So let's just multiply those. So let's take it down here. So now what I'm left with is x squared minus 1 times -1. So I can write that answer either as negative x squared plus 1. So I could write it like that. Or I could write it as 1 minus x squared. Or I could write it as negative x squared minus 1. So any of those answers are fine. I personally like this one that I just highlighted, but this is fine, and this is fine. And actually I'd say these two I like just as much as each other, really. This one I only like a little bit because it's got the negative hanging out the front. So look, it's not wrong, but it would be nice to put the negative after the 1. So just swap those two terms around if you want to leave it like that. All right, that's that. Let's move on. And I feel like this is the last example here. So look, we're almost there. So this one a little bit harder. We've got addition and subtraction of fractions here. We would need a common denominator. But before we do a common denominator, so I guess step 1, identify the fraction rules. So the fraction rules would be common denominator because we're adding and subtracting fractions. So step 2, I'm going to make that common denominator. Actually, I'll factorize first because I'll need to see the common denominator more clearly like that. So let's factorize. So the first one would be 2 over 3 x plus 1. So I've just removed a 3 from that, minus 1 over x minus 2. That one I can't do anything. And then this one, well, I'm going to need to do a little bit more for that, so I'll just take it over here. That is x squared minus x, and that's minus 1x minus 2. And I've written the minus 1 in there, not because you have to, but just because it makes it a little bit easier to see the cross factorization. So x squared is x times x, and -2 is -2 times 1. So let's see. X times -2 is -2x. X times 1 is positive 1x. -2 plus 1 is -1x. And as we see, it is the same as the middle term. So it means these are our brackets going horizontally. So it means that we can write x squared minus x minus 2 as x minus 2, x plus 1. So I'm going to do that. X minus 2, x plus 1. All right, so at this stage, I've done nothing. I've not changed anything. So you'll notice I haven't done anything to the numerator. I haven't changed the numerator in any way because actually I've done nothing to it. I've just factorized the denominator. I've just put them in a bit of a different form. So now what I'm going to do is I'm going to do a common denominator. So as you know from normal fractions like 3/4 plus half, you need to have a common denominator in order to add and subtract them. So I can see that I have 3, and I have x plus 1, and I have x minus 2. And that encompasses all the different denominators here. So now I'm going to do that for each of them. And the last one. And now comes the golden rule of fractions, which is what you do to the bottom, you do to the top. So in this case, I multiplied this by x minus 2. So it could get to this. So if I did that on the bottom, I need to do it in the top. And look at how I've put the brackets there, and you'll see why in a minute. For the next one, I've multiplied this by 3x plus 1. So in the top, I need to multiply by 3x plus 1. So then I have this denominator, all of that. The last one, I've got x minus 2 already. I've got x plus 1 already. I'm just multiplying by 3. So I multiply the top by 3. So this is no magic. This is nothing new for year 11. It's like what you would have done in probably grade 5 of adding and subtracting fractions. But people get a little bit confused because, well, now we're looking at x's and, brackets and stuff. So now what I'm going to do, I'm going to now write my new numerators. 2x, 2 times x, and 2 times negative 2 is negative 4. So I've expanded those brackets here. 1 times 3 is just 3, so 3x plus 1, or no, sorry, not plus 1 at all, plus 3. So that's a silly mistake there. 3 times x is 3x, and 3 times 1 is 3, so you must multiply everything. And then lastly, x times 3 is just 3x. So let's scroll down and let's finish it off. I cannot cross out the denominator, so that's wrong. If there was an equal sign, and after the equal sign I had the same denominator, then we could cross off all the denominators and work with it without the fraction there. And that's important. It's an important distinction that we have. We can't do that because we do not have an equal sign. In order to cross out the denominator, you need an equal sign and a common denominator. So we're not crossing off the denominator, we're leaving it there, but we can simplify it. We're subtracting here. So let's see, 2x minus 4, subtract all of this, 3x plus 3 plus 3x. And I'm just not going to write the denominator yet, but I'm not going to leave it out. Let's see, 2x minus 3x is negative 1x. You don't need the 1 there. You can just write negative x, and actually I will just write negative x. It's a bit babyish to write the 1. Now, next, negative 4 minus positive 3. So negative 4 minus 3 is minus 7. Okay, so we've dealt with those, and then we've just got plus 3x. So let's collect our like terms. Negative x plus 3x is 2x minus 7. And then let's write the denominator in. So our denominator is 3x plus 1 and x minus 2. And we do not expand. So this is just a convention. It wouldn't be wrong if you expand, but it's not what we do. Do not expand the denominator. But we do expand and simplify the numerator. So that there is our final example, and that our final answer, I mean. And this actually also is our final example for today. So make sure, in particular, you can work with quadratic trinomials, cross-factorization. Make sure you know how to factorize quadratics and cubics, and that you can deal with the algebraic fractions. And that is all.